So today is our part 15. Part 15 is on industrial ecology and industrial symbiosis. Am I audible to you?
Yes, sir.
Clearly audible now? Okay.
Yes, sir.
Okay. Then let us start with the first PPT. What is industrial ecology? Industrial ecology is ecology of industry. Ecology comes from the two words ecos and logos. Ecos means the environment, the surroundings, and logos means the science. So the science of surroundings, and when industry is having, so industrial ecology integrates the principles of science, engineering, and ecology in industrial systems through which goods and services are provided, so that the environmental impact is the minimum or the harmful effect of the industry. Any industry will have pollutants, mostly pollutants, so many emissions. All these things may adversely affect our environment, and how we can have an ecology without much spoiling the natural ecosystem. This is discussed in industrial ecology. Or in industrial ecology, we are confined to discussing how the ecology can have minimum harmful effect on the ecosystem. That is it. See the next slide. Before that, in this slide itself, one point. We have studied about the lithosphere, troposphere, stratosphere, ionosphere, etc. And also we have got what is called the anthrosphere. Anthrosphere means that sphere on the earth where the human activities are restricted. So it will be only some feet above the surface of the earth and some feet below the surface of the earth where human beings will have direct interaction. That area is referred to as the anthrosphere. This is the fifth part of the environment because the four parts we have discussed earlier. So industrial ecology is mostly restricted to anthrosphere. Okay, see the next slide. Now, in industrial ecology, what all aspects we take care of? Every industry is meant to provide the human beings with goods and services. And these goods and services, there has to be some production. Goods do not emerge by itself. We should have a system by which we produce these goods and we get these goods. And of course, what will happen to the final product? We have seen the life cycle assessment. What will happen to the final product after years or decades or centuries? What will happen to the final product? So all these things are of concern to the industry, and there has to be a sustainable means of providing goods and services. And it will be most successful when it is mimicking the nature. Last class we have seen what is biomimicking. We have seen that when something is trying to mimic or imitate the nature, its harmful effects will be less because nature always has got a system by which the impact on the human beings is quite less. Nature has got its own control or mitigation measures for all the pollutants and all the harmful things on the earth. So if the industry can also follow those things, the effect is less and the mitigation is more. In that case, the industrial ecology is supposed to be sustainable. See the next slide. An industrial ecosystem means the entire ecosystem produced by an industry and its surroundings. So an industry will have the producer, the distributor, and of course the consumer, and all these people have got different functions. And the producer also will have waste production. The distributor also will have, say, for example, packing, packaging, all these things may come to the distributor. And then the consumer also will have a lot of waste production. Even the commodity may be wasted, or even the packing may be wasted. So all these people are involved in the ecosystem of industry. So industrial ecosystem means right from the manufacturer to the distributor to the consumer, and then to the disintegrating agencies, mostly bioorganisms, which are the disintegrating agencies. All these come under the industrial ecosystem. Let us see the next slide. What is symbiosis? That is going to be our second part. At second part, I'm just giving an introduction to the slide and we'll discuss it at the end. What is symbiosis? What do you mean by the word symbiosis? There is one famous management institute in Pune by the name Symbiosis. They have got some branches all over India. So people know only that mostly when we say symbiosis. Symbiosis means coexistence in a positive way is called symbiosis. Coexistence, we are forced to. We are supposed to coexist with plants and animals on this earth. But when that coexistence is in a positive way, that means it's a win-win situation. We don't harm the others and they don't harm us, then we say it's a symbiosis. In nature, many plants and many animals do have symbiosis. Man is comparatively independent because human species do not have a symbiosis system. But you see, within the human species, we have got symbiosis. See, for example, most of the living animals, say a cow, within an hour of the cow delivering a small calf, the calf will run by itself and will drink its mother's milk by itself. But the human child is one example where years we have to wait for it to be independent, to do things by itself. And of course, the higher the form of origin, like human being, where the intelligence is more, the formative years for the kid is much more. So that is also a form of symbiosis, but it's between the parent and the child. But in nature, the symbiosis is between different species. Even plants need to have, say for example, lichens. Lichen is a plant species which we see in nature. Lichen is not a single thing. Lichen is an algae and a fungus combined. So we can say that lichen is the best example of symbiosis. Two plant organisms. We cannot even define whether fungus is a plant or animal, but two organisms together coexist. That is called symbiosis. See the next slide. What is the industrial ecology production model? Because industrial ecology has got a model. Everything in nature we can model. Like there was a great scientist by name Fourier. You would have studied sometimes Fourier series in mathematics. Fourier was not only a mathematician, he was a philosopher. So he has postulated that everything in nature can be converted to a sinusoidal function. That was Fourier. No, Fourier has defined it by a series. Fourier series is very common. So, like that in some film, I think Tilagan is saying that everything can be put into mathematics. So everything can be put into sinusoidal form is Fourier's theory. Similarly, in anything we can model. Model can be different types. Model can be physical model. Model can be even verbal model. Model can be a mathematical model. Model can be diagrammatic model. A model means what is the flow process in a system. That's called a model. Say, for example, if you have to draw the model of your household, at the top you have your father and mother. At mid-level you have got your elders. Then you have got yourself. Then you have got your youngest. So it shows the flow model of a family. So if it is supposed to be too many generations, all the generations you can show in a particular step. A generation in a step, and that becomes a generation model. So this is only a diagrammatic model. So model doesn't mean people are confused by the term model. Modeling can be done in myriad ways. Modeling can be mathematical, modeling can be diagrammatic, modeling can be networking that we use in networking techniques are very common in management. So all these are modeling techniques, and of course in optimization we use around 13 to 14 systems of modeling. So this is one among the model which is just a diagrammatic expression of the feedback. And of course, I sensitize the organizers. Prabha, please note the final attendance registering should be circulated only after 4:50, because I've seen that the last class some people have left before. So only after 4:50 the attendance circulation should be there. Let them remain for the whole session. We are not going to give attendance for those who are leaving early. Okay. So in this model for industrial ecology, we have got a feedstock, which is the input materials. We have got labor, which is effort, which is required for production, and we in energy. Energy is actually the process converter, and all those things give rise to what is called process. And at the end of the process, we get a product or waste. That which cannot be directly used after the process is called waste. But as I have defined earlier, the waste is a wealth at the wrong place. So many of the waste may be used elsewhere. I quoted the best example of the fly ash, which is coming from the thermal industries, which can be used as a feedstock material for cement production. So like that, waste also can be put as feedstock material somewhere else. And at the end of it, at the end of the process, it goes to the consumer. Consumer may use it, and after that, some of that may be vanishing. Some products may not be visible there at all, and some product will remain waste. It may come back to the feedstock again. That is a procedure. Now let us see the next slide. What are the major components of an industrial ecosystem? This is given in a flowchart or network model. The major inputs are the materials which gets converted into goods, which comes to the user, and then it comes back to recycling. Recycling means whatever is left as waste comes to recycling. So this is the model, and in this model, of course, so many other factors will be there. Energy requirement will be there, transportation will be there, flow, back cycling may be there. Say for example, in thermal power plant, the hot water is recycled again for heating it. Like that, even midway recycling also may be there. So we cannot say that all the input material or the feedstock material is going up to the end. Some of the materials may be used, recycled in between also, so that the quality can be improved. Say for example, when you crush the coconut to make oil, at midway, some coconut cakes you put back to the chunk so that the oil production is much better. Similarly, when you are crushing some orange or something like that, you may the waste also you may put in again to see that the juicing is done better. So process can have need not be a full cycle process. Some process may be half cycle, some may be full cycle. Like that, it can continue. See the next slide. What is the scope of industrial ecology? What are things you can count under the term industrial ecology? The scope is very large. It contains industrial enterprises. It may be small or big, and it may also have constant interaction with each other. Every industrial organization by itself may not be a standalone institution. It may be an institution which is having interaction. And in between this, there may be independent systems, but you need transportation, you need conveyance, and you need interaction. Maybe some rail transport, road transport, all this may be involved. Say, for example, the raw material used in Kerala for the production of something, maybe say rice mills are there in Kaladi. Kaladi is the place where most of the 90% of the rice mills in Kerala are located. And Kerala is unable to Kerala has got only 9% rice production to meet our demands. So 90% has to come from elsewhere. Mostly it comes from Andhra Pradesh and Telangana, and that too mostly by road transport, by lorries and trucks, and a bit by trains also. See, so a production system need not be contained in a small area. It can be contained nationwide, or say, for example, most of the assembly materials in electronics now come from countries like Switzerland, France, etc. So it may be international. Recently, I had a problem with my car, a spare part. They are saying that it has to come from Switzerland. It took 2 months to come. So many production system may be like that. It may have raw materials from far apart to come. See the next slide. So in industry also we have got what is called metabolism. Metabolism, in human being we have got the metabolic cycle. Metabolism means digestion. Digestion means a product is converted into energy and excreta and water. That's called metabolism. So most of the food we take, it's converted into energy, and of course the waste also will be there. Similarly, industrial metabolism means the process by which the materials and components are converted in the industrial ecosystem. That means some raw material you are putting as input material, as the feedstock, it gets converted, and that converted material ultimately becomes a product or a waste or a throwaway, whatever it is. That process is what is called the industrial symbiosis, or it is the industrial digestion rather. You put some materials, it forms into another, and it is used. And it is analogous to the metabolism in living organisms. Like we take food, and the food becomes energy, and the food also gives rise to liquid and solid excreta, and ultimately the body grows and gains its weight, and ultimately the body gets energy from it. Food we are taking for energy. We need energy, and of course the energy is added with vitamins, etc. So metabolism has got all such things in industry also. See the next slide. What are the levels of industrial metabolism? One level is at the molecular level, where the substances are changed chemically. When you put some, say for example, you take silica, most of the silica which is used in Kerala and Tamil Nadu are coming from the western coast of Kerala. From Ernakulam to Tiruvandhuram, the coastal sand is being stolen mostly, and at times with permission, and it is taken away to the glass factories in Salem. Salem Road area, there are so many glass factories. We had one or two good glass factories in Kerala, like Excel Glass Factory. None of them are working because Kerala has got a privilege not to make any factory work. So most of these glass factories are working in Salem Road area, and the raw material is going from here. And you are giving the sand. Sand is basically silica. Pure sand is pure silica, SiO2. That is going to Salem or Erode, and it's becoming glass. Glass has nothing to do with silica because glass is a molten silica. The entire form of glass is crystalline in another form. Glass is called a molten liquid actually. Glass is not a solid. So the form is changed. It is a green molecular change. And of course, in the process inside the factory itself, things can change. Say, for example, the wheat powder is getting into a bread factory. The input thing is wheat powder. The output is bread. So the process inside the factory is converting the wheat powder to bread. And of course, at the industrial ecosystem level also, we can have many products getting into one and one product coming out of it. Say steel, plastic, glass, etc. may be getting into a factory. And what you get out of the factory may be a car or a motorcycle. So even globally, these things can happen. Multiple raw materials can enter into multiple industries, and we get entirely different products like that. Say the cotton yarn, which we used to make in India, used to be taken away by the Manchester companies of Britain. And of course, so they used to give us back the cloth at much higher price. So the raw material which is coming from India used to be used by the British people, and they convert it by some process. So symbiosis takes place, and we get it back at higher rates. This used to be there for 2 centuries. See the next slide. Then what is the waste? We have already learned what is waste. We have studied also solid waste management. So industry may have two types of waste. One is dissipative use of natural waste is there. Dissipative use of natural waste means you can throw away somewhere, it will digest by itself. Another type of waste, you should have some process by which you can dilute, or say for example textile waste. Textile waste is mostly having colored dyes. These dyes will not disintegrate by itself. So what you have to do is you have to separate it, you have to dilute it, and the diluted silage you have to send out to the field, maybe to the paddy field, etc. In Kannur area, this is a heavy environmental issue. So many textile firms are there. Luckily in Palakkad, only 2-3 textile divisions are there. But even there, the output water which is coming out of the industry is having colored dyes. The process is difficult. So material may end up in physical or chemical form, which may be to be treated, to be reclaimed. To reclaim means to get back to the natural form. Everywhere reclamation may not be there, but in Palakkad there is one particular industry, brewing industry, United Breweries. They are having a lot of chemicals input, but they are treating it so well. I've been to there many times, and they are getting almost 99% pure water. So such industries are also there. There, of course, all their wastes are also very valued chemicals. So they want to take it back. So that also happens. Say, for example, in a gold industry, nobody will let out the waste. The waste of the gold industry will also have gold content. That is why the goldsmith, they even sweep their front yard once in a year and see to it whether there is any small particle of gold. Because even that will be hundreds of rupees. So it can happen. So industrial ecosystem has to overcome all the systems by which pollution is there. It has to control the pollution, and it has to take care of the ecosystem. See the next slide. Then the best thing to have the better ecosystem for the industry is to minimize the waste, to minimize the resources, to minimize the input, to minimize the byproduct. Whatever byproduct you get, its value is less than the actual product. No byproduct will be costlier than the actual product. So byproduct is always a losing business. It's not a high cost business. So doing things, especially this happens in extracting the minerals from the ore. We have got copper ore, zinc ore, iron ore, aluminum ore, like that. When you extract the metal from the ore, so much of wastage can come. And that is why I've plotted here the ore industry as separating, there are two types of metal industry. One is converting the ore into metal. Another one is converting the used metal to new one by both by some furnace. Some boiling furnace will be there, mostly electric furnace, that is arc furnace or induction furnace will be there. And we boil either the ore or the used material, which is scrap, both ultimately converts to, and at the end of it, so much of scum will come at the top. Scum means, no, it's a sort of solid waste which is accumulating at the top of a furnace. It's called scum. Just like when you boil milk, you can see a scum layer at top. That scum will be full of butter. That is why when cooling, you take away that layer for making butter. So like that, when boiling a metal or its ore or a scrap in an induction furnace, you'll get thick scum on top of the furnace. But that scum is a mix of so many things. So it has to be thrown away. But nowadays that scum is being reused because that scum is known by the technical term slag. Slag is being powdered and it is being used as an additive to cement manufacture, and you get slag cement. So blast furnace slag cement is very common nowadays, and it is having higher strength also because this slag, which is basically of a metallic content, but with some waste and some rust and all. But in cement, it adds strength to the cement. That is why blast furnace slag is very popular nowadays. Civil engineers will be knowing it. We call it as GGBFS cement, ground granulated blast furnace slag cement. You can get it in the shop, cement shop. It will be written on the back of the cement that GGBFS cement. Okay, see the next slide. Of course, compared to the natural ecosystem, industrial ecosystem is always more polluted. More industries we have, the more polluted the land will be. So natural ecosystems are always better. In natural ecosystem also, harmful things will be there. For example, when the biological materials decompose, they generate methane and carbon dioxide. But the thing is, this methane and carbon dioxide is only up to a certain level where the biological organisms and the plants in the planet can absorb it. That is one advantage. The plants will be able to absorb it. But when industrial production comes, the plants and water, etc., that is why the seawater is going highly acidic, because the carbon dioxide production is so high for the industry, the plants and the nature cannot absorb it, cannot contain it. Say, for example, even poison you can take up to an extent, you will not die. But if the poison goes beyond that level, it's called the tolerance limit, you die. And if the poison goes beyond a particular level, you will have nausea and vomiting, which is an indication that your body is trying to reject it. And even at a later stage, if you take poison, I don't know whether any of you have tried poison, but if you take poison up to a level, you won't feel anything. But when the level increases, you will feel hesitant to take it. The body will try to reject it. And if you are again taking, the body will show symptoms and the body will succumb to it. This is happening in the nature. Industries like taking poison. Up to a level, that poison may be tolerable, we can withstand. But beyond a level, we start resisting it. Our body will react to it. That situation is what is called, the illness which we have created. I was having a discussion with my son on yesterday. He was here, and I was having a discussion with what is the most prominent cause of cancer. He said that pollution is the most prominent. He is an oncologist, so he knows well. So he was saying that pollution is the most dominant cause. And of course, genetic cause is much less. So I asked him what may be the percentage by which you can divide cancer. Cancer can be genetic, cancer can be by pollution, cancer can be contagious. So he says that by genetical nature, maybe around 20%, by contagious nature, around 20%, and 60% will be by pollution. See, 60% will be by the pollution. That means of course, even tobacco pollution may be there. Alcohol is not proved to have much of cancer, but it may promote the growth of cancer. So say 60% of the cancer may be due to pollution. It's a very strange fact because my eldest sister died because of cancer. She was staying in Bombay. Only when she got acute cancer, she came back to Kerala, and her last days she spent here. And I still feel that she would have got cancer because she was staying in Mumbai, because Mumbai is such a polluted place where 70% of the pollution is by industries. 2-3 years I was staying in the Powai IIT campus. That campus is supposed to be comparatively better, but even there you have foul smell always. Always have foul smell, and of course, if you don't have that much of withstanding capacity, you start vomiting. And my wife, when she came over there, she started vomiting and she immediately returned to Kerala. So this can happen. So maybe some people will have more tolerance level, some people will have less tolerance level. That is up to the people. But nature has got its own system. Whatever carbon dioxide nature produces by wildfire or by its own degradation of components, nature has got a system to tranquilize it, to quench it, and to absorb it. But man-made carbon dioxide, nature doesn't have the capacity. See the next slide. So industrial ecosystem is always having excessive production of unwanted things in nature. And of course, the natural ecosystems, natural ecosystem has got its own inbuilt control system, mostly microorganisms. Many of the microorganisms on the earth, in the atmosphere, do absorb carbon dioxide, do degenerate chemical pollutants. Even I have told that once, even oil-eating bacteria are there. But so many of the cyanobacteria do eat metals. So even metallic pollutants are even taken by bacteria. And of course, you know that that is all very limited. Man is producing much, much more than that. And of course, the most common pollutant which we increase are the nitrous oxides, the carbon oxides, COX, NOx, SOx, sulfur oxides. These are the common pollutants. And of course, recycling can reduce a lot of pollutants because by recycling the waste, you are reducing the quantum of pollutants which is directly entering the earth's surface as the pollutant. It's going as a raw material for some other production. See the next. You will see a small video on industrial ecology. This is a longer video, but I just want you to see only the first 5 minutes of this video just to see an introduction to industrial ecology. Just see.
In the previous module, we talked about the idea of the Anthropocene. In the previous module, we talked about the idea of the Anthropocene as a recognition to the fundamental effect that industrial economies are having on the global ecosystem. In this video, we will continue on with this theme by talking about the subject of industrial ecology. Industrial ecology has arisen over the past few decades as the study of these coupled environmental and industrial systems, offering us a systems-based approach to modeling, designing, and managing industrial systems in relation to the natural environment. Industrial ecology as a subject is both interdisciplinary and holistic. Thus, it is a very broad area, giving it a number of different interpretations. The most expansive definitions interpret it in a generalized sense as a means to achieving sustainability. But this is a somewhat open-ended definition. A more common definition would read something like this: industrial ecology is the study of material and energy flows through industrial systems. Or on its most practical level, it may be understood as simply a set of tools for achieving energy efficiency and high environmental standards through life cycle assessment and material flow accounting, among other tools that are commonly used in the field. Although industrial ecology only really came of age in the 1990s, its foundations were laid in the decades before this. Robert Ayers is recognized for bringing together many of the basic ideas that have comprised industrial ecology since the late 1960s. He pointed to the importance of examining material and energy flows in a systemic framework, both in order to truly understand them and to develop effective policies for managing these resources. His work was groundbreaking in that it introduced thermodynamics to the area. Ayers was one of the earliest scientists to bring second law notions into industrial ecology, and his work stressed the importance of exergy as the proper measurement in studying industrial energy use. The term industrial ecology was then popularized following the publication in 1989 of a seminal article in Science America by Robert Frost and Nicholas Galapagos. Following this event, the field developed during the 1990s and it spawned many academic programs, several journals, and an international society. Today, the influence of industrial ecology is significant and growing, and the analytical tools that are central to the field are increasingly used in other disciplines. Recent publications in top scientific journals signal the coming of age to the field. On a more practical level, industrial ecology principles are also emerging in various policy realms, such as the United Nations and China recently promoting the concept of the circular economy. Probably the foundational and overarching insight of industrial ecology is, as the name implies, understanding industrial economies in relation to and as extensions of natural ecosystems. A recognition that both industrial and natural ecosystems are made from the same basic materials and substances and subject to the same basic thermodynamic principles governing their structure and dynamics. Industrial ecology is based on the same general paradigm as the Anthropocene, that is to say, a recognition that industrial economies are now deeply embedded within the global ecosphere, and that we now need to develop synergistic solutions for integrating the two systems in order to enable their sustainable coexistence. Within this context, industrial ecology can be seen as the practical solution for designing and managing sustainable systems of technology. Thus, a central idea here is that of biomimicry, where biomimicry means the imitation of the models, systems, and structures of ecosystems for the purpose of designing and managing industrial systems. As such, it is an approach to innovation that seeks sustainable solutions to human challenges by emulating nature's patterns and strategies within ecosystems, natural solutions that have evolved over a prolonged period and have withstood the test of time to prove themselves as sustainable and effective. Industrial ecology includes a number of principles that underpin the subject and form its theoretical
Okay, so we'll come back to the slides we have been discussing. As I told, there are two systems, the natural systems and the industrial systems. And the natural systems or the biological systems have got its own control. They are self-regulating. Whereas the industrial systems, the regulation also has to be human. We have to impose certain regulations. So some of the ethics which you have to follow for industrial systems is one thing is that don't produce unwanted things. More, even this is applicable to even your household. You know how many people are there in your house and how much they eat. So cooking extra rice and extra vegetables and wasting them, it's a criminal offense. You are doing injustice to the nature. So you have to take only that much rice and that much vegetables or that much meat which is necessary for you. Maybe throwing away waste, you can show off that you are a rich person, but rich people never do it because they know richness is not wasting. Richness is in the mind of the person, not the money the person has got. So richness means getting satisfied with what you're having and living a life of containment. That is richness. So don't think that wasting some, you just see what is the lifestyle of very rich people. They don't waste anything. They use only what is meant for them. They're one of the richest the kings in India. I used to visit his tomb because I was so fond of his activities. Aurangzeb was a very rich person, but he used to earn his livelihood for daily livelihood by by making clothes by himself and selling it to people. So rich people do have that. So don't think that wasting things are rich. So have a commandment unto yourself. Say that I'm not supposed to waste. If I am wasting, it is injustice to the entire humanity, not to yourself alone. So that way you have to limit the resources. And dissipating resources to the surroundings and polluting the environment is not at all a symbol of civilization. It's a symbol of mediocrity. It's a symbol of primitiveness. So civilization means you have to understand that you have no right to waste the nature's resources. See the next slide. This is a network diagram for the level of recycling and embedded utility. You see, this shows an industrial system where the materials, the raw materials convert to finished materials, convert to fabricated materials, convert to assembly line, and ultimately it becomes the product. And then that product, semi-finished product, which cannot be used, will come back to the assembly line. Whereas fully finished products will go to the customer or consumer. And of course, if it is very rude or very crude material assets, it may go back to the material side. Anyway, everything you can have a recycling. So at the end of it, you can reduce the quantity of materials used for making new materials. This is happening as most of the metallic plants. It is happening. If the purification is not proper, metallic purification is not proper, it will go to the semi-finished goods again and will get again purified. See the next slide. Cogeneration. I don't know anybody knows what is cogeneration. I think there are some electrical people and some mechanical people here. Let me see how many of you know the point of cogeneration. What does it mean? So that without me explaining, let me see. Please come to the chat box and tell me who knows what is cogeneration. I'm on the chat box now. Please see. What do you mean by cogeneration? Anyone? I think electrical people are the best people to say what is cogeneration. One is there. Okay, one comment has come. General, both heat and power. So Shailesh Kumar has given that it is general both heat and power. Then Mr. Ashwin has written solutions designed to generate heat and power. Then Mr. Ajmal has written on-site generation of electricity from waste heat. Okay, right. Any other? I think I'll explain with a case study. Long back, some 2 decades back, I was a regular visitor to NDPC Kayamkulam, not for a engineering consultancy, but I was supposed to train their staff. For staff training purpose, I used to visit there very frequently. At that time, some of my former students who are working there used to take me inside the plant. Inside the plant is a protected area. Only their staff can visit, but I, being a guest of the company, they used to take me inside. So there I have seen that, basically in a thermal power plant, the energy generation is by a fuel. By a fuel means Kaingalam has got the facility for coal as well as naphtha at that time. Now I think 2 more fuels are permitted there. I think furnace oil is also permitted now. At that time when I used to visit, it's long back, the initial stages, they had a 2 fuel facility, coal and naphtha. When I visited, once naphtha was running, earlier coal was running. And then huge, concealed, huge sealed pipes are there which are coming from outside the plant. Inside the plant, it's being fired. Either coal is being fired or naphtha is being fired. And obviously, when coal or naphtha is being fired, high temperature is generated. That temperature will boil the water, and water will become steam, and that steam will drive steam turbine. And the steam turbine, of course, it is revolving in a magnetic field. It will generate electricity. That is a basic principle. But when this is being done, the entire turbine area, the steam turbine area and the heating area will be covered by cold water pipes. Cold water pipes are kept around all around. That is why Kayangulam power plant is on the Kayangulam backwater, so that water is plenty available. And this water is being recycled, and of course the water is running around the entire area, and that heat is being absorbed by this cold water. So by the time that heat is coming up out, it will be almost generating steam. So that water, that hot water, is again used for, it is again sent back to the boiling water, and that heat is being partially recovered. So that means the first part of energy they are getting from burning the fuel. Another part, maybe less in quantity, very small in quantity, they are getting from the heated water, which is used for cooling the system. So this is the basis of cogeneration. This is one method of cogeneration. Another method is that at the same place, two principles are used for generating energy. Say we are having sunlight which is falling, and wind is the same unit is using both sunlight and wind to work. So we can say this is a cogeneration. Means more than one method is used for generating either electricity or heat or any form of energy. We call it as cogeneration. So mostly it is used in electricity generation, in steam generation, and in hot water generation. Say, for example, sunlight, we have got two methods of solar heating. One is direct solar heating, and one is, converted solar heating by means of storage equipments and all. In both, of course, cogeneration means more than one method is adopted for heating or electricity generation. We call it as, say, somebody has written here, on-site generation of electricity from waste heat actually. Okay. All these things, of course, if there is more than one source, we call it as cogeneration. See the next slide. Then many places is combined power cycles should be there. Combined power cycle means, this is what I've told about Kainglam. Combined power cycle means one cycle maybe the fuel is being burnt. This is the best example of what I told about Kainglam power plant. One cycle, the heat is being generated by combustion of the fuel, and that generates heat and it drives the steam turbine. And another place, the heat is recovered. The heat is recovered from the steam, and of course that steam turbine is again used for generating the electricity. That is secondary generation, or it is cogeneration. So combined power cycle can be there. See the next one. Then in industrial ecology, of course, what about the material saving is very important. Any eco-friendly method will have two things basically: material saving, resource saving, or energy saving. And of course, in the higher occurrence of science and technology, energy and material are basically the same. But both, of course, in the physical form, both are different. And of course, in dematerialization is one method for saving the material. For example, if you have a lesser conducting uh, equipment, you don't have to use heavy conducting materials. You can save the material. Say your electrical appliance is only, say, 2 ampere. So you don't need a 15 ampere switch, and you don't need a 15 ampere wiring. You can get sufficed with 5 ampere wiring, which we normally give for a single phase. So a 5 ampere wiring will be sufficient to take all the load coming in that. Of course, if you expect more load, you can go for that. So wasting the material can be avoided as much as possible. Similarly, I always say that when you need less power for a vehicle, why do you go for a higher power? Say most of the small vehicles, say 1,000 milli capacity engines will be there. Maruti used to have 800 to 1,200 uh, milliliter capacity engines. But heavy vehicles may go up to very heavy, like powerful vehicles like Benz or BMW may go for even 2 liter, 2.5 liter engine. And of course, that is why when a Maruti may give you a mileage of 25-30 kilometers, a BMW may give you only 5 to 6 kilometers. Even that is very high. Normally 3 to 5, because the engine capacity is high. So similarly on the industrial side, if you don't need higher capacity things, don't install that. Install only that which is required for you. And one more thing is substitution can also be there. If some abundant supply is available with you, why should you waste the rare material? Some materials may be rare. So that is why now in cement production, this concept has come. Cement is normally produced by limestone and of course clay, fine clay. And limestone is of course costly material. Fine powdered clay is also costly material, but we get a cheaper material which is called fly ash. So now most of the cement have got 20% replacement by fly ash or by what I said earlier, the slag, the waste material produced in steel industry. So this replacement by cheaper materials can reduce the use of original raw materials or virgin raw materials so that the recycling of the materials are much more possible. That method is called substitution method. See the next slide. Recycling and waste mining. Recycling, one best example of recycling is paper. Paper, of course, is one material which is recycled multiple times. Only thing is when you are recycling paper with ink in it, its whiteness may be a bit dull. But newspaper print doesn't require that much white paper. Only virgin paper you require white color because you have to your A4 pack or something like that. You need a white colored paper. But for printing a notice or printing a flyer or for printing newspaper, you don't require a good quality papers. That paper we call as the newsprint paper. Newsprint paper is mostly coming from recycling. That is why it is pretty cheap also. So similarly, most of the metals you can use it scrapped for producing the new material. And that is very common in iron and steel industry because 90% of the iron and steel in India is recycled ones. Only 10 to 15% are virgin iron ore. Similarly, the waste mining, we can extract a lot of new materials from the waste, whether it is plastic or whether it is, of course, in some materials which are biodegradable quickly, like leather. This recycling may not be that easy, but up to an extent, even that is recyclable because though it is biodegradable, up to a certain extent, it may be recyclable. So most of the materials, whether it is copper or aluminum or iron, these are replaceable. And of course, one more thing is when we have got a dump of waste, a landfill, or an accumulation of waste materials, gases will be emanating from there, methane, carbon dioxide, etc. And out of that, methane can be collected and be, that is a biogas principle. Methane is collected from degrading material and it can be used for can be used for cooking, it can be used for producing heat energy. And many places in India, there are furnaces which make use of recycled methane gas from biological degradation. See the next slide. So industrial ecosystems are diverse in nature. Like the earth is diverse, nature is diverse, human beings are diverse. The industrial ecosystem is quite diverse. You cannot equate one system with another. And the way in which the system can work also will be different. You cannot have the same recycling system everywhere. And diversity and robustness. Diversity and robustness are some of the original principles by which the nature works and the industrial ecosystem works. So you will have definitely all this diversity when you're going for the industrial system. Don't think that one system is applicable everywhere. The system may be different for different places. See the next slide now. And what are the environmental impacts of industrial ecosystem? Each system will have its own impact. Of course, obviously, all the systems will have two, three things in common. Carbon dioxide emission is common everywhere. And water is also coming as a waste in most of the things. Most of the industries will have water for different purposes. For production, for processing, for processing, for washing, all these things we may need water in different systems. So whether it is one type of industry, whether it is production industry or process industry or any even food industry, everywhere water will be used in different systems and they have to have uh, treatment after the use so that we get better water out of it. And obviously, many times even water vapor may add to the effects of greenhouse warming. Though carbon dioxide is the most prominent one, even vapor has got greenhouse effect. See the next slide. Not only industry, even agriculture do have environmental effects. Agriculture means, in many places, agriculture is one of the cause for air pollution. Aggressive air pollution in North India is mostly caused by the firing and burning of agricultural waste. Similarly, the water which is used for irrigation, the water which is used for cropping, the water which is used for washing the agricultural produce, all these things. And nowadays, one more dangerous thing has happened, because whenever the agricultural produce is having pesticides in it, it is being washed, and even that water becomes, the wash water also becomes poisonous. That is happening now all over the world. So even agricultural activities can also give rise to environmental impacts quite naturally. See the next slide. So when we design an industrial ecosystem, who designs the industrial ecosystem? Engineers design it. Every production system has got its own design. So when we design an industrial ecosystem, we also have to see that we are minimizing the environmental impact. That means minimizing the waste, minimizing the emission of volatile organic compounds, eliminating the waste, and of course using the most efficient system, reducing the resources, reducing the water use, all these things you should have to, and reducing the uh, heat emission also. A very good industrial system should have minimum heat production, because heat is also a pollutant, and minimizing the heat production is also an equivalent. It's an important requirement for reducing the wastage together. And of course, in buildings also, this I will discuss in detail. In buildings, we can reduce the heat loss by so that we can reduce the energy loss by reducing the heat loss, and by containing the embedded energy and the operational energy. That I will discuss when we come to the next portion, which is on energy. See the next one now. I'm taking a case of cars, how an industrial system is going to affect us. Car is a thing which is a product known to all of you. And how the car is manufactured, I've not got the latest, that would have slight change. Let us take a car. This is only a standard which is taken. In 1950s, the car used to be heavy. And in India, we used to have the ambassador, that was nearly almost 1.7 tons, 1,700 kg. But the Maruti, which many people are having now, have got only around 1,200 kg plus, or even some of the lighter vehicles are 1,000, 1,100 kg only. Let us take two cases. One typical car, you name it as A or B. In 1950s, say a car was having 1.9 tons weight, and 1990 it is having 1.434 tons weight. What will be roughly the contents? You see the change from metallic, it has changed over to plastics, and from heavy metals like steel, it has reduced to light metals like aluminum. See the change? This is a sustainable change. You are reducing the weight of the vehicle, and you are, of course, that plastic is something which is of a concern, but the plastic used in the vehicles are recyclable. Plastics which are used in the vehicles are naturally recyclable, not like the throwaway carry bags. You see the change? Plastic in 1950s was zero in a car, whereas in 1990s it was more than 100 kg in a car. Aluminum was zero in the 50s. You know, in the early 50s and all, aluminum was supposed to be one of the very costly metal. Aluminum utensils used to be kept only at the residence of the lords and the rich. Common man couldn't afford an aluminum vessel in the early 20th century. But only in the second half of 20th century, aluminum has become so cheap. Now it is pretty cheap. Anybody can afford to have some aluminum vessels. And copper also slightly reduced. Lead is highly reduced. Why? Because lead is a heavy pollutant. When you are going for lead manufacture, lead has got a peculiarity. In the vehicle also lead is there. Earlier in the fuel also lead used to be there. We used to have leaded petrol, but now in the Bharat 6 or BS6 standards, lead is permanently avoided. Lead is not there in the fuel right now. We are using what is called unleaded petrol, where no lead is there, because lead is highly poisonous also. But as a metal, where lead comes mostly in the vehicle circles, the vehicle networks, lead is normally in the soldering material. The soldering, the solder material is having lead and tin in abundance. So There it comes. Then zinc reduced, iron almost the same, steel heavily reduced. Steel is actually iron alloy. Earlier, the vehicle mostly used to be steel content, but now it has a bit reduced. And glass content also has reduced because glass is heavy weight. That is why the glass has otherwise no problem, but it is fragile and it is heavy weight also. And one more thing is, most of the glass elements in the car, there is no insurance coverage. Otherwise, you'll have to go for special insurance. Normal insurance is not there. So, like that, the rubber content has reduced, the fluid content has reduced, and other materials also have reduced. See the next slide now. Now, aluminum is going at a heavy pace right now because most of the space vehicles now are aluminum alloys. Most of the space vehicles. Umpteen number of even kitchen utensils. Earlier, aluminum used to be very scarce. Nowadays, Indalium is an aluminum alloy, which is one of the most common alloy now used in kitchen. Most of our pressure cookers, heavy vessels, pans, etc. are basically Indalium. Indalium is lighter compared to iron because it's aluminum alloy, but iron content is also there in Indalium. And of course, they are slowly replacing the steel because they are less dense and they are more conducting than iron and such compounds. So an indalium alloy is getting hot quickly. So that means energy saving is there. Then they have got less emissions compared to many other metals. And they don't get oxidized immediately. Oxidized means rusting. Iron may get oxidized. You would have seen that if you used to have a China tray, what is that called? China chatti. If you used to have that Chinese pan at your home, you would have seen that over the years it would have rusted. But Indalium doesn't get rusted. When copper plate, it gets covered by its oxides, copper oxides, green copper oxides may be there, whereas Indalium doesn't get like that. So its use is coming up, and so it is less polluting. That is what I wanted to focus. Aluminum alloys are naturally less polluting. But nowadays, people say that aluminum can cause Alzheimer's. I don't know. Aluminum, to my knowledge, aluminum cannot cause that much Alzheimer's, but certain medical bulletins have come saying that aluminum is also causing some. Excuse me, I'll switch off my phone because it's somebody is ringing very commonly. Aluminum alloys are also causing Alzheimer's. It's a belief system. I don't know. But Alzheimer's is such a disease, the studies are still going on. People do say nowadays that even parallel processing of your brain can lead to Alzheimer's. In that case, I would have got it long back. I used to do parallel processing from very young age, at a time doing 2, 3 things parallel. I don't know whether it will affect. Anyway, till now, no signals. That means nothing can be ascertained. I come to the next slide. So, when aluminum is used in vehicles, transport vehicles, space vehicle, etc., weight is reduced. When weight is reduced, you save a lot of fuel. And of course, over the lifespan, the fuel economy, that is what this graph shows. When the total weight is reducing, the fuel economy, fuel requirement also comes down. Similarly, over the lifespan, the fuel economy is very high. I have always made it a point to buy vehicles which have got high fuel economy because compared to the purchase cost of the vehicle, the running cost is very high. So if you buy a vehicle with less mileage, naturally its operating cost will be very high. So lightweight vehicles are commonly having better mileage compared to heavy vehicles. That is why I tell two examples which I myself had. The Opel Astra car, which used to be almost 1.5 tons to 2 tons, it used to have a mileage of 12 to 16 kilometers per hour. The Ford Fiesta, which is only 1.2 tons weight, it has got a mileage of roughly 23 to 28 kilometers per liter. See the difference, almost 80% extra. That is the advantage of using a lighter vehicle. Maybe if no one is bothered about the cost, even then you can be concerned about the environment. The more fuel you burn, the more you are harming the environment. At least that environment friendliness point of view, better to go for vehicles with more mileage. See the next slide. So the aluminum production is now coming up in large quantum. And I think one of the classes I told earlier, the most abundant material available on the Earth's crust. The Earth's atmosphere, the most abundant is nitrogen. But on the Earth's crust, the most abundant material available is aluminum, not even silica, aluminum. And the silicon is the second one. And the third one is iron. This I think I explained once. So aluminum is abundantly available, and India is so rich in aluminum ores. So maybe in the future, aluminum will be more common than even in construction side. Aluminum has got an advantage. It's very lightweight, so the supporting structures, the columns and the pillars have to be very light in weight. And moreover, aluminum we can have hollow structures with more moment of inertia, so that its structural rigidity can be. And moreover, it is easily recyclable. Aluminum can be easily recycled like iron. In iron, when you recycle around 20 to 30% rusted waste may be there. The aluminum, the rusting may be, rusting is not there, but even the oxidation may be very light, up to 1 or 2% only. That is the advantage of aluminum. So from the industrial ecology point of view, aluminum is one of the most prominent metal we can use. See the next one. So aluminum cans have been used widely in the 90s and 80s. Now I think last class I explained, now the Tetra Pak is becoming more popular because Tetra Pak is degradable, biodegradable. Aluminum you need recycling. But even in 1998, in the United States alone, 3.4 million metric tons of aluminum was processed and made virgin aluminum. Again, new aluminum. Almost 37% was recycled. See the next slide. So I took an example of vehicle, then metals. Now let us see, in general, having an industrial ecology. How come industrial ecology come? We have to decide ourselves that we are going to have an industrial ecology. We are studying an industry, you are not concerned about the society, you are only profit oriented, you are not concerned about the coming generation. There is no concept of industrial ecology there. Industrial ecology comes into picture whether you are concerned about the fellow beings, you are concerned about the people around you. In that case only you can discuss what is called industrial ecology. So it is basically a humanitarian aspects for an industrialist. So you can have industrial ecology within the firm, you can have in the value chain. Say for example, many of the Western companies will insist some certifications, some standard procedures to be adopted in your organization if you want to sell your product to them. Otherwise, they won't accept. Then in the production chain also you can have an ecological procedure because waste minimization at every step, every stage. That is also possible. See the next slide. And of course, in a big company, we may say, when I was discussing the quality concepts I told, better the quality, lower the expense. Quality doesn't attract more expense. It's only a pseudo feeling. Quality actually improves the performance and reduces the cost also. Similarly, if you go for industrial ecology, in the long run, we will have cost saving because we are resorting more to what is now, we have got a concept nowadays, what is called frugal systems. I don't know whether you have heard it. Frugal, frugal systems. Frugal system means just sufficient material, just sufficient energy, just sufficient time. You are producing the product without wasting time, energy, or material. That is called the frugal system. Now, frugal production methods are very popular. This was initially introduced by the Japanese, and of course, Taguchi was one of the persons who was keen on introducing the frugal system. So, the frugal system implies that without losing materials, without losing energy much, we are producing the required product at a competitive rate. So, you will have a better image then. Say, for example, most of the Japanese products, the damaged products are very less. That is why when you go for buying a Sony television or for buying a Sony musical system, we have got very less doubt that it may go wrong because By tradition, it is 100% perfect. That is how you can become a market leader. They don't waste materials, they don't waste energy. They have got a production system which is just in time and just intact. Just in time, we call in management as JIT or JIT. Of course, it can also be interpreted as just intact of the Japanese system. See the next slide. Then there are so many barriers to industrial ecology. One barrier is that you should choose a material which can be recycled. If you are choosing a material which cannot be recycled, then the ecological system cannot survive there. Then sometimes initially the cost of recycling may be very heavy. Earlier, we never used to make recycled paper because wood was plenty available, timber was plenty available. But nowadays, timber is very costly. That is why people are thinking of recycling the paper, so that new paper, new newsprint comes from the old purpose. Then many times unawareness, that is information barriers may be there. We may not be aware of the process by which we can do it. And then organizational obstacles. Say you are working in a company, your company doesn't want to recycle things. Your company want to only dispose the waste. Your company is not concerned about the cost. There are certain industries which are never concerned about the cost because they have a high-end user and they have got a brand name. So they are not concerned about the frugal economy or the frugal production system. And such things can be barriers to the development of an industrial ecology. But over a long time, such people who don't properly focus on the industrial ecology will be outdated and will be thrown out. That can happen. Then sometimes the regulatory mechanisms do not permit you. Regulatory mechanisms do not permit you because the government rules may not be sensible. Especially in countries like India, the rules must be pretty old. And I still remember a company insisting that application has to be submitted in triplicate in printed form. They don't accept soft copy because their rule, which is a government rule which is pretty old, do say that they have to give the application only in printed form, and that too in triple copy. See, and it's a wastage of effort, wastage of resources, but their system is like that and they cannot come out of it. Maybe after 20, 30 years, they'll come out with the new system. By that time, the world would have still changed. This can happen. Many of our organizations, that's why I used to always say that at home, we are in the 18th century. On road, we are in the 19th century. And in our laboratory, we are in the 20th century. And when going through such webinars, we are in the 21st century. This is a dilemma which our civilization is meeting with. Okay. See the next slide, please. So it can be implemented at micro scale as well as macro scale. Macro scale means big scale. Micro scale means very small scale. In between, we call what is called mesoscale. Mesoscale means moderate. So any process, even small things, say you are cooking only 1 kilogram rice at home. Even in that, if by some planning you can save 100 gram of rice, it's an industrial ecology concept there. Of course, a domestic, you can say it is a domestic ecology, but even there, similarly, instead of using 1 ton of steel for making a particular product, if you can save 50 kilograms of steel in that process by designing the process properly, by reducing the conspicuous consumption, naturally it conforms to industrial ecology. So saving need not be high. Any saving in material or energy conforms to the practice of positive practice of industrial ecology. See the next one. Now we are passing on to what is called industrial symbiosis. Industrial symbiosis. I explained to you the term symbiosis earlier. Then what is industrial symbiosis? Read that statement which is written there. I would like to tell a small story. The lockdown period, a dog and a cat they have come to my home. They are still here. I don't know from where they have come. The dog is always on the front side of my house. We never invited it. It feels as if it is our own and stays there. Whenever we need, we will push it off. And the cat is on the back side. So what is happening is when some waste materials, waste food is being put out, they have got an agreement between them. Some food only the cat will take. I don't know how they made that agreement. Some food the dog will take. So they are not fighting each other. They have some understanding. This understanding is symbiosis. Give and let live. I think you understood now. This is what is called symbiosis. So some industry has got some waste material. They find someone else who can use it. Similarly, maybe a return also may be there. So that is a statement which is written here. I think you would have read that statement. I'll just read it. That statement may be a bit confusing, but meaning is this. It's a systematic coexistence of industries. Industrial symbiosis is the use by one company or sector of underutilized resources broadly defined, including waste, byproducts, residues, energy, water, logistics, capacity, expertise, equipment, and materials from another, with the result of keeping resources in productive use for longer. It presents a systems approach to a more sustainable and integrated industrial economy that identifies business opportunities to improve resource utilization and productivity. I'll tell you one typical example which I know very well. So I'm right now staying in Palakkad. I have got my house at Kayamkulam and my wife house at Tirunelveli, where I have built my own houses. So many times I may have to transport heavy materials from there. So what I do is I go to Palakkad Bazaar and just check which are the lorries going to Trivandrum for delivering the banana and such things which are coming from Pollachi. So there are lorries which go from here and go up to Trivandrum to deliver these things, vegetables and banana and such things. And on return, they are coming back. Okay. So I just inquire with the agent at Palghat which lorry is coming back and I have to pay only half the rate. Otherwise, if I'm taking one lorry to Tirunelveli and bringing back, I'll have to spend around 25 to 30,000 rupees for that. But this vacant lorry, whatever I give, it is profitable to them. So even by 10,000 rupees, I may be able to bring back a full lorry. So it's a transportation symbiosis arrangement. Whereas they are having onward trip and when returning, they are getting something to carry and whatever they get, that is beneficial to them. Anyway, they have to come back. So this system, similarly, in all transport materials, see, even pooling of your car can be a symbiosis. Some 5 people are going to the college. Each one take car one day in a week. So others do join them. That is what is called carpooling. Carpooling is a symbiosis. This is the meaning of symbiosis. So when industries do it, either for transportation or for materials, then we say it is a symbiotic arrangement with the industries. See the next slide. I've told in our last classes that there are two systems of production, the linear system and the circular system. In the linear system, the resources, natural resources are going directly as product and waste. Waste you throw away or you reuse. Mostly in linear system, the waste is for disposal. Whereas a circular system is there where the waste is being reused again to make products. That is called the circular system. That is the lower one which is. And a circular system is the best example of a symbiotic system. See the next one. So what is the rationale of symbiosis? Cooperation with some partners so that natural resources can be reduced. That's all. You can reduce the natural resources by exchange, by sharing, by coexistence. That is the rationale of industrial symbiosis. Say, for example, you would have seen cow sitting on, uh, you know, crow sitting on cow. Very commonly I've seen. Nowadays, crows are very rare. In my childhood, I used to always see that crows are sitting on top of the cow. The cow never disturbs it because sitting on top of the cow, the crow will eat away the small insects and small worms which do come on the body of the cow. So the cow is also relieved and the crow gets its food. That is a biological symbiosis. Like that, the industries do interact between them. See the next slide. Of course, what are the strategic benefits? Knowledge sharing is there. Then the reduction of impact, environmental impact reduction is there, and economic value is there. That is very important for an industry. Your cost of production, cost of sustenance, cost of pollution control comes down when your material sharing is there, waste sharing is there. That is one of the advantages. Now, see the next slide. So, basic principles. These are the basic principles. Industrial symbiosis refers to all kinds of resources utilization in a shared way in the industries. And the symbiotic principles always follow economic profitability because waste is converted to wealth. And of course, industrial symbiosis can happen in organized structures. Organized structures means there can be well-laid policy for industrial symbiosis. That is also there. Okay. I think that is the last slide I've got in this one. Please see the next one. One more is there. Elements of industrial symbiosis. That I've already discussed. You can just skip it. Now we will come to the next part 16. This is part 16, energy. I'm not very particular that this part should be finished today because next two parts are also going on energy. On 17 will be on renewable energy, 18 will be on other sources of energy. So 16, 17, 18 will be on energy. So if something is not completed in this session, we'll continue that in the next session because 16 is the basic introduction to energy. 17 and 18 will be focusing on renewable energy and advanced technologies in energy. See the next slide. This is a household energy use a decade back. And that is 2005, not 1 decade, 1.5 decade back. Latest I haven't got, otherwise I have produced that. So here it is shown the comparison between 1990 and 2005 of different countries. What is the percentage used by share of energy? See, for example, each country, two parallel lines are there. The leftmost is OECD countries, that is European countries. Then, of course, India also you can see two lines are for the same country. And of course, India is 1, 2, 3, 4, 5, sixth set from the left is India. And it shows the pattern of use of different forms of energy in different country for household purpose. We will see what is household purpose and non-household purpose. For household purpose, let us see that dark blue line is renewable energy. Which country is using the maximum renewable energy in the world? Which country is using the maximum renewable energy in the world? Just see. Even now, every country have got two power lines, 1900 and 2015. You can put on the chat box which country is using the maximum renewable energy. Shailesh Kumar has written India. Any other answer? Yes. Only one person has responded. Others are doing some other business, it seems. People are marking the attendance today. Ashwin Raj has written Germany. India. Elizabeth has written India. It is true that percentage-wise, India is the highest use of renewable energy. And till last century, till 20th century, just before the steam engines have come, steam engines came at the end of 18th century. At that time, it was not available in India. In India, the steam engines came from to the Binni factory first, and then to the railways in the mid of 19th century. So that means around 180 years since the engines came to India. Yesterday, I was seeing some posting put by someone in a group showing the first buses which have run in Kerala. First bus which was run in 1920 or 22. And first route bus in 1950. I have seen that. Anyway, India had only renewable energy till the mid of 19th century, whereas the West, the industrial sector started using man-made energy right from the end of industrial energy right from the end of 18th century. Can you tell me some of the sources of renewable energy? Of course, whenever we say renewable energy, we always forget one most important renewable energy. That is why, and India is the country where that renewable energy was highly being used. Can you just list the renewable energy? I see whether somebody remembers that renewable energy. Just put in the names of solar is there. Then Bushra has written solar. Then wind, again Bushra has Ashwin has written wind. Then hydro, yes, Shailesh has written hydro. Rohit has written solar. Then tidal, Shailesh has written some other. Agash has also written baby Tessie solar, wind. Then geothermal. Then Shailesh has written geothermal. And Shailesh has written biomass. Most important is being missing in this. That's why I'm asking. Anjana has written sunlight, wind, rain, tides, waves, geothermal. Then one of the most important is missing in it. That is why I wanted you to write. And that was our only source of energy. We cannot say only source because solar energy has been used from time immemorial. Right from the beginning, man has been using solar energy. After that, Ashwin has written gas. Gas is a recent invention. Gas couldn't be used earlier. Then Shailesh has written nuclear. Nuclear, of course, for the last 60, 70 years. Agash has written coal. Elizabeth has written waste. Ashwin Raj has written gas. Then Ramesh Krishnan has written cow dung. These are all forms used for energy. Cow dung can be burned to energy. But the main point is missing. That is why I'm asking. Let us see whether any brain is working. Again, Bindu has written wood. Ashwin has written diesel. One of the most important form of renewable energy is missing here. In many of the textbooks also, sometimes it is missing. And I wondered why. Till 18th century, the most important form of renewable energy for us was animal energy. You understand now? We used animals for transportation. We used animals for agriculture. We used animals for even turning the mills. We used animals for riding. All these were dependent on animal energy, and it is one of the most important form of renewable energy. If you go on giving food, it will use its energy. Even for warfare, we used animal energy. You get what I'm saying? This is one form. Even now, it's a dependable source of energy. Most of the villages, when India got independence, 80% of the Indians were living in villages. Now it has changed. Now in Kerala, 50% of the people are living in towns. Earlier, bullock cart or a horse cart were only forms of transport. Till around 60, 70 years back, I told that the first bus in Kerala came only in 1920, but bus transports came only in 1950, 1947 to 50. Before that, we used to have only bullock carts. I still remember a story. My grandmother, my father's mother, died in childbirth. She got the labor pain. There was no cars available. Bullock cart came. The nearest doctor was at 7 kilometers distance. The bullock cart came and she was taken. And 2 kilometers from the home, that would have taken at least 1 hour. Bullock cart, how far it can go? Maybe 2 to 3 kilometers away from the home. She succumbed to death. She couldn't reach even the doctor. Why? The fastest mode of transport at that time was the bullock cart. Horse cart was not that popular in Kerala. Individual horses were used in warfare and all. So see, that is our history. But animal energy, many times we forget. Okay, that is also, but it is not listed here because in many countries, animal energy was not that much used like we in India because Indians are basically animal lovers and not animal killers. That is why this Gomada deal and all going on because basically Indians, irrespective of religion, used to like animals, used to love animals. Unlike in the, of course, the Arabs used to love also animals. Camels were their pets, but camels are not a love animal like the cows or buffaloes or something like that. Their culture is slightly different. Anyway, I'm saying that that is being ignored nowadays. Maybe I foresee that in the future, some source of energy can be still animals. We may come back to the past civilization at least for a part. At least for fashion, we will come back to animal energy. Quite possible. And of course, India is still having the largest share of renewable energy in different forms. Which are the renewable energy which are shown here? The renewable energy which are shown here, of course, this is that blue color is the renewable energy totally. The other forms of energy shown here are oil. Oil is red color. What about the use of oil? It is increasing. In many countries, in most of the countries, it is increasing, but all over the world, the oil use has come down. The reason is that oil cannot be replenished. Oil is a fixed stock inside the earth. Once it is over, we will have to wait for millions and years for new oil to generate. Otherwise, we'll have to go for making natural substitutes like that. In Brazil, they have got the oil, plant-based oils are there. Jatropha plants they grow and they get oil out of it. But that is not the crude oil which we get from the crude oil which we get from the soil is having more calorific value, and of course it is processed means it is very good oil. Okay. Now see the next slide. You will see a small video on energy. It's a very simple video just to update you on energy. Then we'll come back to the next.
Smile and learn.
Let's find out what energy is, what its properties are, and what types of energy exist. Energy is anything that has the capacity to produce a change in matter. If you look around, you'll see that energy is present everywhere. For example, cars move thanks to energy produced by motor combustion. The blades of the mill start moving thanks to the energy produced by the wind. We can walk or jump thanks to the energy we get from food. You should know that energy can neither be created nor destroyed. Energy can only be transferred from one object to another. For example, energy in the air can be transformed in electricity, and this can be transformed in thermal energy to warm a room by means of a radiator. We obtain energy from two sources, renewable and non-renewable. Renewable energy refers to all those limitless energy sources present in nature, like wind, for example, sunlight, or sea waves. Non-renewable energy refers to the limited energy sources that we exhaust with use, like oil or coal. Energy possesses 4 fundamental properties you should know about. Energy transforms. For example, when we use a battery for a flashlight, the chemical energy in the battery transforms in electric energy. Energy is transferred from one object to another. For example, when we mix hot and cold water, thermal energy passes from hot water to cold water. Energy is transported and can move from one place to another. This way, energy travels through electric cables and reaches our houses. Energy can be stored. For example, mobile phone batteries are used for storing energy. Let's recap. Energy transforms, is transferred, and can also be transported and stored. Thermal energy, that is also called heat energy, is transferred with heat. Mechanical energy is created by 2 objects owing to their movement. Electric energy is carried by electric currents. Chemical energy is found in substances like food or fuel. Light energy that is present in the light. Eolic energy that comes from the wind. Or hydraulic energy, which we obtain thanks to the flow of water. It's easy to understand that energy is essential for life because it causes all changes to occur in the world around us.
Did you like the video?
Before proceeding to the next slide, Prabha, can you hear me?
Yes, sir. Yes, yes.
Some people
Hello?
have left, and you can mark them as absent.
Okay, sir. Okay.
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 And let us see what is the global energy demand by sector in 2008. Why 2008 is I don't have the data with me for 2020. 2020 will be a proportion of this, and you just see what is the percentage by which energy is used in industry. Industry, that light green color shows industry use, and then that brownish green shows residential, commercial, and agriculture. The dark green shows transportation. And you just see which is the country with the highest industrial usage of energy. It's not USA. USA is the last one. But the highest energy use for industry is in China, even now. Today's exact percentage, I don't know. This is 2008 statistics. But I know that China is still the highest energy user. In China, there are many places where there is no electric connection. But still, the industrial use of energy is the highest. And see, they have got very less use of energy for transport because China, they don't promote the private transport that much. The public transport system like trains and buses are much more popular. Whereas in a country like India, we have got a lot of, say Kerala, we have got nearly 3.4 crores of population and around 1.5 crores of vehicles are here. That means every house having at least one vehicle on an average. A household may be 3 or 4 people. So on an average, 1.5 vehicles per household in Kerala. So in India also, the number of vehicles density is much higher than that in China. But public transport system is higher there. That is why they don't spend much energy for transport. But of course, from the other points of view, just see next to India, next to China, India is using energy for production. In Kerala, we don't have energy intensive production. But in the north, we have got very highly energy intensive production. But don't think that we are using a lot of energy. The total energy consumption in India is only 1/5 of that of US. Just see. And not only that, the US population is only 1/5 of that of India. That means our per capita consumption of energy is very, very, very low. But even then, the percentage of energy used in industrial production compared to other purposes is high. That's all. This figure doesn't know that we are consuming more energy than US or Europe. No. Our consumption of total energy is much, much less. Because the use of energy is a status or symbol of the development of a nation. Going with that development of that index for the development, US is at a very high position compared to India. That is true. But if 100 units of energy is used, how it is shared, that is what is shown here. So it doesn't mean we are the highest user. Next slide, please. Consumption of energy increased 3 times from 1970 to 1920. And if you see that curve shape, that curve is coming asymptotic. That means in 2050, it may be 10 times. You extend that curve and see where it will go. From 1995 onwards, it is going up and up. In 1970, the consumption was around 200 quadrillion British thermal units. BTU stands for British thermal units. It can be converted to watts or kilowatts if you want. Conversion factor is there. And of course, in 2020, it is 600 plus BTU, quadrillion BTU. Quadrillion means, quadra means 4. Trillion, you know. Trillion is 1,000 million. So 4 into 1,000 million British thermal units. Okay. And let us see the next slide then. So energy use is going up and up. Now, oil and natural gas, it is coming down. Why it is coming down? Why oil and natural gas use is coming down? Because cost is going up and up. But remember, in transportation sector, it is still going up. Whereas, energy production by oil is coming down. Energy production is more by thermal or more by nuclear. All over the world, coal is number 1 fuel in energy production. Oil is not there because oil is comparatively very costly compared to coal. Oil, 1 kilo oil will be almost around 8 to 10 times 1 kilo coal. So naturally the cost is high. That is why the oil use has come down from 2010. See the next slide. Energy conservation efficiency can buy time. Means if you want more efficiency, it can be less timing. Okay. If you want more efficiency, especially in some areas, it may consume much time. In solar, that is one best example. Efficiency is very less right now. But maybe over the time, it may come, it may reach. See the next slide. From 1970 to 2025, see the use of, I told that oil use is coming down. Oil means petroleum. See the different elements which are in use: petroleum, renewables, nuclear, natural gas, coal. Coal use is going up and up over the years, and coal is used for electricity generation. Kerala, almost we need around 3,500 megawatts power daily. And Kerala production is around 1,500 and 1,475 megawatt. We have got hydropower. All our thermal power plants together can give only around 300 to 400. That means almost half of the energy in Kerala is purchased from elsewhere. And most of it comes from Ramagundam in Andhra Pradesh and Neyveli in Tamil Nadu. A small fraction is coming from Tirunelveli and another fraction coming from Kalpakam, thermal. Kalpakam is thermal. Tirunelveli, you know that it's a nuclear power plant. Kanyakumari district is there. It is nuclear only. So Kerala, major share as of now is thermal. Earlier, which was having sufficient hydropower. in the 70s, late 70s, 79, 80 period, Kerala was having around 1,000, around 700 plus units of megawatt energy here production. Requirement was much less than that. We sold hydropower energy to other states, but thing has changed. So this shows this is taken from a standard journal. That is why figure number is given. I have not drawn it. It is taken from a standard journal. And in that it is given how the coal use is going over years and years. And if you go on using like this, the coal may last for only 50, 60 years more. After that, coal may not be used. Coal may be only in museum thereafter. But natural gas is now being more and more used. But natural gas also will become extinct. Natural gas is gas coming from the Earth's crust, where the decomposition takes place of the petroleum products and the gas is coming. So natural gas also, we cannot expect for a long time. That also will end. And by the present estimate, natural gas may end within 30 to 40 years. Coal may still more last. And petroleum products, if we continue with the same pattern, it may last for 40, 50 years. See, petroleum use is not increasing, only gradually increasing. Reason is that petroleum products are comparatively costly. But there are some requirements which cannot exempt that. They say aviation fuel. You have to take from petroleum products. Aviation fuel is a petroleum product. You cannot have any other substitute for aviation fuel. See the next slide. You see in 1975, 76 and 2004, how the pattern has changed based on production. Earlier I have shown this in a bar chart form. You see that in 2004, the world is more dependent on coal than petroleum. Petroleum production has come down. Petroleum-based energy production has come down from around 15 point something to 3 point something. Reason is exorbitant cost. Earlier petrol was pretty cheap, but when the Organization of Petroleum Exporting Companies was formed, countries was formed, OPEC was formed, they started pricing the petroleum higher. That is why the Gulf countries have become rich. But when those countries became rich, naturally, the use of petroleum has gone down. And of course, the nuclear has gone up. But nuclear has gone up, and after the late 90s, it has come down. You know what is the reason? After the Chernobyl disaster, the nuclear power use has come down drastically. That indicated that whatever you claim, whatever is the safety measures you claim, a nuclear power plant has got always a susceptibility for breakdown. Nobody, even now it is there. 99% it may be safe, but 1% unsafety is built in. And hydroelectric power plants have declined in use because environmentalists all over the world were fighting against hydropower plants. They say that when the hydropower plants come, the natural flow of the streams are blocked, the natural greenery is blocked, and of course, in the name of constructing the reservoirs, thousands of hectares of forest land is being lost. These things have come up. Maybe that is the reason. See the next slide. Energy costs from different sources. I told that coal is widely being used because it is the cheapest form. One of the reasons for the cheapness of coal is its abundance. Abundance, if you go to a state like Bihar, thousands of kilometers square area is only coal, when the surface is coal. Underneath, if you go, I have gone to a coal mine in Bihar, Charia mines. You are mining at 500 meters depth, 500 meters to 1,000 meters depth. That means half a kilometer, 1 kilometer you are going inside. And you are mining there in horizontal pattern. That means above this huge hollow, the earth is still standing. And if at all some fire occurs in a mine, the entire thing will blast because coal will catch fire immediately. Fire control is Jaria mines once had a fire also. A big fire was there, but people were saved. That is why before you enter the mines, they take from you an undertaking that if something goes wrong and your life is lost in the mines, you are not they are not responsible for it. And it can happen many ways. Fire can be there, even entire falling and subsiding of the mines can be there. But coal is still pretty cheap because coal in Tamil Nadu there is plenty of coal deposit. In Neyveli area, in Trichy area, plenty of coal deposit is there. But that coal is a bit lesser quality coal. It is called by the name lignite. So this figure shows the cost of different forms of energy. You see coal is the cheapest, oil is the next, and then biomass is the next. Then electrical energy is the highest cost energy. Electrical energy is produced from any of the other things. But now, recently I have seen that electric cars are huge energy savers. Somebody was telling me that the per kilometer cost of an electric car is coming to only 30 to 40 paise per kilometer. Whereas now our diesel or petrol car will be from 3 to 10 rupees per kilometer based on the car. So that's a range. That is 1/10 of the cost of a fossil fuel you can run on electric car. So it is going to catch all the market. And the real fact is that the corporates in India are preventing the electric cars from spreading in India. And within 5 to 10 years, this has happened with the mobile phones earlier. BSNL was a hindrance to bringing mobile phones at a time. But now you see that within 5 to 10 years, electric cars will be very popular in India at affordable rates. It's a change which we foresee right now. So anybody who wants to buy a car, please wait for 2 more years. The electric car, which are very costly now, will come down in cost. See the next slide. Yes. Now, when the fossil fuels run out, I told that for transportation, now we are exclusively dependent on fossil fuels, diesel or petrol or similar things. India, the transportation, whether it is even railway, is only partially electrified. Many routes, the railway is dependent on diesel engine, and earlier we used to have the coal engine. Now, coal engine was very common in Kerala with so much of dark dust coming from it. Now, diesel engine, naphtha engine, and electric engine are now the common things. But in the years to come, electric engine will take over fully. And of course, nuclear engines, I don't know whether the nuclear engines can come, I'm not sure right now. Right now, we don't have any nuclear engine for trains in India. And of course, what are the other sources when the fossil fuels? Once I was asking this question to the Ashok Leyland general manager, some long back, I think around in the early 90s, some 30 years back. Ashok Leyland general manager he's a Keralite, I forgot his name. He was here at NSS College of Engineering to conduct a campus interview. At that time, I asked him a funny question. See, the fossil fuels, oils are going to vanish. What you will have? Ashok Leyland is fully dependent on oil-based vehicles. What you will have then? He said, anyway, the world is going to be affected equally, not only Leyland. By that time, the new technology will come, so we will also change accordingly. True. But even now, that even after 30 years, they are still producing oil-based engines. Leyland has not started even electrical engines. Maybe in some of the Western countries, Leyland is making it. In India, they don't have electrical engines right now. So when the fossil fuels are ending, what are our solutions? Our solutions are renewable energy. One such renewable energy is nuclear fusion. Nuclear fusion means hydrogen atoms combine to form helium, giving out huge quantum of energy and water. That energy will be heat energy totally. This is what is happening in the sun. In the sun, this fusion process is happening. Another is what is called fission. Fission means the helium atoms can separate themselves into form what is called individual hydrogen atoms. What are the other sources possible? All these things we'll discuss in detail later because I told energy is there in 2 more sessions. See the next slide. What are the other sources possible? Solar, wind, water. Solar, winds, very common now. Solar winds, Now, I told that we are also setting up 500 kilowatt solar power plants in Ahilya campus. And it takes a lot of space. That is the difficulty. People have come up with some suggestion. One of my friends has suggested that the reservoirs, the ideal reservoirs, water reservoirs should be having solar panel so that no extra space is required. In Cochin Airport, you would have seen solar panels occupy a lot of space. Buildings are not sufficient because they have all the operation based on solar panel. Wind has got some advantage. Wind doesn't need that much space. I told that in Ahilya we are having 500 kilowatt solar power plant, which is around 2.5 acres land taken for that. Whereas we are having 8,100 kilowatt, 8,400 kilowatt wind energy, which is contained in 4 windmills. Each windmill is having 2.1 megawatt power. Almost 4 megawatt is enough for our campus. We produce 8.4. So that means windmills are more compatible and more adjusted for land restrictions are there. We have in Ahilya campus, we have located 164 locations for windmills. One by one, we will construct it also. 164 locations means wind is available, and wind has got one more advantage. Even if it is taken by one windmill, the same wind goes to the other windmill also. It is not consumed. It is only used and sent as such. Like water. Water is used, say for example, Periyar Valley is using, and the same water is coming to Lower Periyar. The same water is coming to 3 more dams below it. So same water can work on many dams. Head difference is there. See the next slide. These are all possibilities which we are seeing. Geothermal. Geothermal means the temperature inside the earth we are utilizing. Temperature inside the earth, 2 ways you can utilize. When temperatures are inside the earth, steam will be coming out. That steam we can use for running steam engine. That is one thing. Another thing is we can have that temperature inside to boil water. We can pump in water and boil water we can take out. Again, steam can be produced. So both ways. There are some natural hot springs which we call geysers. Natural hot springs and volcanoes are there. Hot springs are there. In Punjab, there are some hot springs. Our hot water is coming from the Earth's mantle. Earth's lithosphere. We can utilize it. So geothermal is one such crop. We will discuss all these things in great detail later. See the next slide. Now, solar energy we can have in 2 ways. One is chemical energy, which we use in fuel cells. Similarly, we can have photovoltaic, where the light energy is used to convert it into electrical energy. The photovoltaic is there. And of course, the plants are also using the solar energy for photosynthesis. So, we can have 3 systems of solar to energy. One is photosynthesis of the plants. Then the next is the combining of hydrogen and oxygen, which will give, that is the basic principles of fuel cell. Combining hydrogen and oxygen, which will give a lot of energy. And the third is a photovoltaic cell, where the temperature difference of a hot end and a cool end can be utilized for making energy. That is the concept of photovoltaic cell. See the next slide.